I would like to welcome back Dave Linder. This time, Dave will show us some useful tools for vector calculus. Welcome back, Dave.
Yeah, there's a bit of confusion, I think, sometimes with these packages. There's the student version of these packages. There's the regular version. There's the multivariable calculus, the vector calculus, and then the student version and the main version have some differences between them. So the basics, of course, are that the vector calculus package is meant for a higher year calculus student or user. It supports a large number of coordinate systems. The main package supports most of I think, the coordinate systems that Maple supports, in a sense at least that it accepts those for input that may be converted at some point to Cartesian coordinates. There's not always ability to do the reverse computation. But you can do general things like to turn a vector field get a vector field in spherical coordinates, get those coordinates, set the coordinates back to Cartesian, and so on and so forth. I think where the real interesting stuff happens is with all of the different kinds of vector. The main vector calculus package has vector fields, but then it also has three different kinds of vector. In Cartesian coordinates, the three different kinds of vector sort of meld together, and they not so much of a distinction between them, but in some of the other coordinate systems, they may be different. And so the full power of the package proper offers these three things. There's a description in the help page of what they are. The basic idea is that a free vector, which is just created with the vector command, it just has a coordinate system attribute which defines the end of the vector, supposed to be based at the origin. A position vector, they're usually interpreted using transformations to Cartesian coordinates. So there's a bit of that always sort of converting to Cartesian behind the scenes aspect. But they're also rooted at the origin. And then the rooted vector allows you to specify a different kind of root, as well as our coordinate system. Anyway, so there are examples which illustrate some of the things you can do, and then a vector field, which is a formula which you can instantiate values for the variables, so you can evaluate a vector field at a point. The angle brackets denote the vector command, which is an export of the vector package. There's a vector command in Maple proper, but the package exports its own version of the vector command as well as the constructors. By default, the display is to show you the coordinate vectors, the unit vectors, and then their coefficients. And you can do all kinds of usual vector calculus type computations, arc length, curl, a number of different path integrals, the sort of things you would expect to see or have to teach students in a course. Position vectors, again, you can define the coordinate system, but then you're going to get components at a root point with Cartesian system for them. The rooted vector, again, you can ask various aspects of it as well as create them and then use them. Vector fields, I'm going to create a spherical example. And I can now evaluate this vector field at a point. So I'm going to evaluate it at the point 1 pi over 2, 0. And I get values. I'm not sure why I'm seeing the dots instead of the 1, but and there are a number of different computations. There's quite a lot of computations for this package. I'm not sure I can show them to you in the help page because I'm sharing the app and I had some trouble showing help before. But the overview, the details page, sorry, the vector calculus details page contains a full list of all the commands that are exported from the package. It's quite extensive. There are computational routines, there are visualization routines. Both packages have their own set of those. And you could actually run through some of these commands, and there's also an example worksheet. The example worksheet runs through a lot of different examples. Examples like this divergence example, it goes through and it shows you as well for the curl one. I think it actually goes through step by step as if you were to do it by hand and show you how you can arrive at a result equivalent to this in a more step by step manner to sort of guarantee to yourself that it really is correct. As I said, the details page has the full deal. And then there is a description on the student vector calculus package about all the differences. The student vector calculus package designed for functions from Rn to Rm, as opposed to the multivariable calculus, which is designed for things from Rn to R. Generally, m is greater than 1 here. It's not going to R, and m and n are usually less than or equal to 3. In the student vector calculus package, it only has the vectors and the vector fields and scalar functions. As I said before, there's this idea that in the Cartesian system, some of the distinctions between position vectors and root vectors don't become necessary and may actually end up confusing a student. So that package is kept a little simpler. However, there is a command convert vector which can convert from some of these vector forms from one to another. And then there's other auxiliary commands which don't just do a computation in the usual sense that we know of, but actually will also change basis. For example, you can change the coordinate system for a vector or a vector field. And I'll just give it a quick example. I've set the basis format false, which means I get a sort of a vector look rather than that coordinate view I was getting before, where I have the E and the X and the EY term as unit vectors. So here I get just one look of the vector with just the coefficients. That's just how it's formatted. And I can simplify the map to basis for polar and get a result, which again can be done by hand to get the same result. The examples help page is actually a worksheet which contains quite a few examples that illustrate how the package is used and how it's designed. I don't have much else to say except there's a lot of material there. And if one is interested, going through the examples page as well as the overview and the details page is probably a good idea.